so with all that said, I was sitting here thinking to myself, what would happen if you actually had a lightsaber? Because when a lightsaber cuts through something, it leaves little glowing edges, which could be taken to mean that it uses heat to do its job. So if we boil a lightsaber down to just a thing that uses heat to instantaneously cut through something, well, things get pretty destructive rather quickly. Let's say that in order for it to be instantaneous, it has to be done at 10 milliseconds, and for the purposes of making it more interesting, we'll say that a lightsaber just vaporizes stuff, boils it off in the blink of an eye. So let's pick something that our lightsaber has to cut through, something hard to vaporize, like, say, tungsten. We'll use a 1 centimeter cubed section of a tungsten bar as a benchmark. If it can cut through that, it can probably cut through most other things as well. So, how much energy would the lightsaber have to dump into the tungsten in order for it to melt? For this, we'll turn to physics. The energy required to heat something up by some number of degrees is given by this, where m is the mass of the thing, delta T is the change in temperature, and C is the specific heat, a number which is specific to the material. This can get us to tungsten's roughly 3,500 degree Kelvin melting temperature, but in order to find out how much energy is required to melt it, we need a new formula, Q equals mL. Again, m is the mass, but now L is the latent heat of the material, which is how much energy is required for this substance to melt or vaporize, and this number is going to be different for both melting and vaporizing. So if we find the energy required to bring it to melting temperature, plus the energy required to melt it, plus the energy required to bring it to boiling temperature, plus the energy required to boil it, we get this monstrosity, which is equal to about 100 kilojoules of energy. But we're not done. We need to supply this energy in 10 milliseconds, which means this 1 centimeter cubed section of lightsaber needs to have a power output of 10 megawatts in order to vaporize our tungsten. And that means that if we were to turn our lightsaber on, in the same time it takes to vaporize our tungsten, the air that it touches would become several times as hot as the core of the sun. Now, it wouldn't actually get that hot since the air would rapidly leave the vicinity of the lightsaber, but I don't think we need to do very much calculation to conclude that it's probably not going to be a very fun experience for the wielder.